কথা বলো না, ক্লাস শুরু হচ্ছে। Good morning, children. Welcome back to the next class of carbon compounds. If you remember, in the previous class we have discussed about ethanol. In today's class, we are going to discuss about ethanoic acid. The ethanoic acid is also called as acetic acid, and its formula is CH3COOH. Ethanoic acid is very popular by its common name, that is acetic acid. It is generally present in many types of fruits, and they are sour in taste. And they are sour in taste. Okay. A dilute aqueous solution of the acid containing 5 to 8% of the acid is called as vinegar. It is used for the preservation of sausages, pickles, etc. It is used for the preservation of sausages, pickles, etc. Okay. Now, preparation of ethanoic acid. How ethanoic acid is being prepared. A number of methods are available for the preparation of the acid. We are discussing the preparation from ethanol and methanol. Here we have from ethanol. So this method involves the slow oxidation of the dilute solution of ethanol by oxygen present in air in the presence of an enzyme called acetobacter. So what we do, we take ethanol, oxidize it with the oxygen present in air in the presence of enzyme like acetobacter. What we get ethanoic acid, which is used as vinegar and water. Okay, which is used as vinegar and water. The acid obtained is in the form of dilute solution called as vinegar. The acid obtained is in the form of dilute solution called as vinegar. Now, next is just from methanol. These days, ethanoic acid is manufactured by the reaction between methanol and carbon monoxide in the presence of iodine, that is called rhodium. What is that? Iodine rhodium catalyst mixture. So in this reaction, what we actually perform, we take methanol. This methanol is made to react with carbon monoxide in the presence of a catalyst, and in this case the catalyst is iodine and rhodium catalyst, and we get acetic acid, or we get it as ethanoic acid, CH3COH. So there are two basic methods for the preparation. The first method is from ethanol. When ethanol is made to react with oxygen in presence of acetobacter, we get ethanoic acid plus water. The acid obtained is in the form of dilute solution called as vinegar. Okay. And the next reaction is from methanol. Nowadays, what we do, we take methanol and we just react this methanol in presence of carbon monoxide, in presence of iodine and rhodium as the catalyst. We get acetic acid as the important product. After that, we are going to discuss, but before that, I'm giving you 2 minutes time. If you want to copy down this reaction, please copy it down. You can copy down these two reactions for the preparation of ethanoic acid. Just copy it down, children. I hope you have copied it. I'm giving you 2 minutes time. Just copy it down. Then we will discuss the properties of ethanoic acid. I hope children you have copied it. After that, see, we are going to discuss the properties of ethanoic acid. The first property of ethanoic acid is that ethanoic acid is a colorless liquid with a sour taste and has a typical vinegar smell. It is a colorless liquid with a sour taste and has a typical vinegar smell. It is miscible with water in all proportion. This acid boils at a temperature of 391 Kelvin. On cooling, pure ethanoic acid just freezes to form ice-like flakes. They just look like glacier. Due to this property, pure ethanoic acid is often called as glacial ethanoic acid or glacial acetic acid. So just remember that whenever acetic acid is cooled, this acetic acid on being cooled, it changes into ice-like flakes, and this type of cold acetic acid which is having ice-like flakes is called as glacial acetic acid. It is called as glacial acetic acid. After that, we have the next point, that is the chemical properties. The chemical properties are that the chemical characteristics of the acid are mainly of the carboxylic group, that is COH group. So acidic nature. Ethanoic acid or acetic acid, as expected, is acidic in nature. The acidic nature can be tested by dipping a blue litmus strip in a tube containing acetic acid. Immediately change the color to red. So just remember, as acetic acid is acidic in nature, it will change the color of the blue litmus to red. Okay. The second point is that it will change the color of methyl orange, whose initial color is orange, that would also be turned to red. So these are some of the reactions by which we can say that acetic acid shows its acidic nature. Okay. After that, see, ethanoic acid or acetic acid, as it is been called, it is actually a type of weak acid. Weak acid means it is a type of weak acid. Weak acid, that means it is much weaker than that of mineral acid. It is much weaker than that of the mineral acids. Okay. See some of the common mineral acids: the hydrochloric acid, nitric acid, sulfuric acid, but acetic acid is much weaker than the normal mineral acid. This can be confirmed by comparing their pH values with the help of pH paper or pH meter. So what we know, that our mineral acid like hydrochloric, nitric, sulfuric, they are much more stronger, but on the other hand acetic acid is a much weaker acid, and that's why it can be used directly. See, we can use acetic acid in our food. You know, the acetic acid is used in all types of Chinese preparations, right? It is used to marinate meat and fish. Why we can use it directly? Because it is much, I should say, weaker. Because of its weaker nature, it can be used. Okay. Actually, see, ethanoic acid and other organic acids are weakly dissociated, while hydrochloric acid and other inorganic acids are almost completely dissociated in water. After that, we have reaction with metals. Now, ethanoic acid evolves hydrogen on reacting with active metal present of hydrogen in the activity series. So, what we know, that when a metal is placed in acid, it actually reacts with the metal to form the corresponding salt of the metal, as well as hydrogen gas is being evolved out. So here are some of the reactions. We have acetic acid that is made to react with sodium. We get sodium acetate, hydrogen gas is coming out. If we take calcium, we get calcium acetate and calcium ethanoate, or calcium acetate, as well as hydrogen gas comes out. After that, we have neutralization reaction. Now, what is neutralization reaction? Before that, I'm giving you 2 minutes time. Please copy down this reaction. Please copy it down, children. I hope you have copied it, children. After that, we are discussing utilization reaction. So, what is a utilization reaction? A utilization reaction is a double displacement reaction in which a acid reacts with a base to give salt and water. So, as you could see, we have acetic acid that is made to react with a strong base like sodium hydroxide gives sodium ethanoate plus water. We have acetic acid that is made to react with sodium carbonate that gives you sodium acetate, water plus carbon dioxide. We have acetic acid that is made to react with sodium hydrogen carbonate and gives you again sodium acetate or sodium ethanoate, carbon dioxide plus water. So, in a neutralization reaction, acid is made to react with the base to form salt and water. Okay, in case of this reaction between sodium hydrogen carbonate and ethanoic acid, carbon dioxide gas is evolved that is accompanied by the brisk effervescence. What is effervescence? Bubble formation. Okay, it also turns the color of lime water milky. Why? Because carbon dioxide gas reacts with calcium hydroxide to form calcium carbonate. That's why lime water turns milky. The reaction is used as a test for ethanoic acid and other carboxylic acids. Now, reaction with alcohol. Then we have esterification reaction. What is esterification reaction? Esterification reaction is a reaction in which organic acid is made to react with alcohol to form a compound called ester with the evolution of a molecule of water. So monocarboxylic acids they just react with alcohol to form ester and water. This the reaction is called esterification carried out in the presence of concentrated sulfuric acid. So we have acetic acid that is made to react with methyl alcohol, and in presence of concentrated sulfuric acid we get methyl ethanoate plus water. Then we have acetic acid plus ethyl alcohol. Again, in presence of concentrated sulfuric acid, it actually forms ethyl ethanoate plus water. So, what is the acidification reaction? It is the reaction of an acid. Monocarboxylic acid will react with alcohol to form ester and water. So, esters can be easily formed in the laboratory also. See, we have organic acid, we have alcohol. If I change the alcohol or the organic acid, I will get this corresponding ester. So, take equal volumes of ethyl alcohol and glacial acetic acid along with a few drops of concentrated sulfuric acid in a test tube. In the meantime, the warm water in a beaker as shown in the figure. Keep the test tube in the warm water for some time. You will experience a pleasant smell. This shows that ethyl acetate has been formed in this reaction. This shows that ethyl acid has been formed in this reaction. Now, esters, as pointed, are pleasant smelling compound. They are therefore commonly used as a type of flavoring agent. When an ester is reacted with water in the presence of a dilute acid like hydrochloric acid, alcohols are formed as the product. The reaction is called as ester hydrolysis. So when we take the ester, we just react with warm NaOH, we get back the corresponding alcohol and the sodium salt of the acid, and this reaction is called as ester hydrolysis. Okay, so I'm giving you 2 minutes time, children. Please copy down this reaction. I hope you have copied it, children. See, after that, we are moving to the next part of the chapter. Here, what we see that when a ester is subjected to acidic hydrolysis, that gives you corresponding acid and alcohol, right? So we have ethyl ethanoate that on acidic hydrolysis will give you acetic acid as well as ethyl alcohol. Ester hydrolysis is the reverse of the esterification reaction. It is actually the reverse of esterification reaction. When an ester is reacted with aqueous solution of a base like NaOH or that of KOH, the product is the alcohol and the salt of the acid. For example, see we have ethyl ethanoate that is made to react with sodium hydroxide. We get sodium ethanoate plus ethyl alcohol. Now this ethyl ethanoate plus KOH, we get CH3COK plus C2H5OH. Okay, C2H5OH. This reaction is known as saponification reaction because it is the basis for the formation of soap. It is the basis for the formation of soap. This reaction is known as saponification reaction because it is the basis of the formation of soap. Okay, it is the basis for the formation of soap. Now, uses of ethanoic acid. Ethanoic acid or acetic acid is used. What are the uses of ethanoic acid? Uses of ethanoic acid are as follows. See, ethanoic acid is used as a solvent in industry as well as laboratory. It is used for making dyes, perfumes, and medicine. It is used for making synthetic vinegar. It is used for making basic copper acetate, which is used as a green paint. So, basic copper acetate is used as a green paint. It is also used for making aluminium acetate, which is used in preparing water for poor fabrics. For preparing water for waterproof fabrics and as a laboratory reagent for carrying chemical reactions. These are some of the use of ethanoic acid. I'm giving you 2 minutes time. Children, just copy it down. After that, we will discuss about the distinction between ethyl alcohol and acetic acid. How will you distinguish ethyl alcohol and acetic acid? Okay, the first test we have is the distinction between ethyl alcohol and the acid. Both ethyl alcohol, acetic acid has a acidic smell, but how will I identify which one is ethyl alcohol, which one acetic acid? So what we do, we just take two identical test tubes. In one of the test tube we keep ethyl alcohol, in the other test tube we keep acetic acid, right? In both of them we add litmus paper. What color litmus paper we add? That is called blue litmus paper. If we see that litmus paper color changes from blue to red, that actually confirms that your sample is acetic acid, because acetic acid changes the color of blue litmus to red but ethyl alcohol remains unaffected. Okay, so I'm repeating the test once again. We take two identical test tube. In one test tube we put ethyl alcohol, in the other test tube we put acetic acid. In one of them, both the test tube we put, that is called blue litmus paper. If the color of the blue litmus paper changes, that means that test tube contain acid, right? Now the second test is with sodium hydrogen carbonate test. The distinction can also be made with sodium hydrogen carbonate. That is, we take two identical test tubes, we put a small pinch of baking powder or sodium hydrogen carbonate. If it shows the formation of bubbles, or if there is, that is called brisk effervescence, then that actually confirms the presence of acetic acid. So it is the effervescence formation that confirms the presence of acetic acid. If effervescence does not take place, then that is ethyl alcohol. So this is how we distinguish each of them. So have you understood it, children? I'm giving you 2 minutes time. If you want to note it down, please note it down. Okay, please copy it down, children. Okay, children, that was all for the day. Goodbye. Thank you.